Okay, this is number 4. The graph of the following equations is a straight line parallel to the graph of y is equal to x. So I didn't write down all the multiple choice because I felt like it was a waste of time, to be honest. So I wrote down the first 3 possibilities and we'll go over them. If it's not one of them, then I'll point out which is the correct answer through explanation. So when we're talking about parallel, the important key word to figure here, it's like what's important here is that you realize what makes 2 lines parallel. The thing that makes 2 lines parallel is the slope. Now you might also not know what parallel is, but okay, here is our Cartesian plane, here's the x-axis, here's the y-axis. If I were to draw a random straight line like this one, and I wanted to figure out what's parallel to this line, I would have to get the slope of this line and just basically create another equation that has the same slope but different y-intercept. If you notice, all of the possible parallel lines that you can make with this line is based upon its change in y-intercept. Look, if I shift this line down, it creates this. Now it's the exact same thing, it has the exact same slope. The only difference is, where does it intersect with the y? Here it's intersected here, right? And here it intersected, so here it's 0, and here let's say it's -2 for randomness. -2, maybe if I were to shift it more downwards, the y-intercept would be -4, or I could shift it upwards and the y-intercept could be 2. But the point is that the only possibilities for these lines to be parallel is if we shift them upwards or downwards, and that's what changes. Like if we have y equals mx plus b, the slope has to be the same for 2 lines to be the same. But remember that b represents the y-intercept, right? And that's the thing that changes between lines. So for example, if I gave you this line, y equals 2x plus 3, right? The slope is determined by this coefficient in front of the variable of x. So then all we do is that if we wanted to generate a random parallel line, all we would have to really do is change the y-intercept. So we could say that y equals 2x plus 5, or we could say -5, and these are all possibilities that will still generate parallel lines to the original line that you wanted to create its parallel lines. But so all we have to do is just change the y-intercept for these problems. Keep in mind that you cannot change this even to a negative, because when you change it to a negative, what it does, it flips it around the y-axis. So if the line was like this, if you flip it to a negative, it's gonna go the other direction. Okay, so the other direction. Wait, the other direction? Let me see. Equals -2x. Yeah, that's right. And so now the next thing is, sometimes equations aren't that subtle. Like this is the equation of a line right here, y equals mx plus b, but the equations given to you, for example here, they are not in the equation of the line form. You know, they're not in standard form. So what we have to do is we have to isolate the y, put the mx first, and then the y-intercept. If you notice our equation, y equals 2x, that's our original line. So we're going to write that y is equal to 2x. Well, technically it's y equals 2x plus 0. So that means that our y-intercept is going to be on the center of the Cartesian plane, the center. So the next thing is that we're going to take the first possibility A, we're going to write it down. Let me erase this one. Whoops. Let me see.